Musical linguistic objects.
Greetings from Cyberdelic Space. This is Lorenzo, and I'm your host here in the Psychedelic Salon. And before I introduce today's program, I'd first like to thank a few of our fellow saloners who either made a donation to the salon or who bought a copy of my novel, the Pay What You Can audiobook, The Genesis Generation. And those fine people are Sean B., Rob P., Michael E., Karen L., Stuart P., Robin B., and Andy H. And hey, I really want to thank you all so much for your continuing support. I know a lot of you have been with us for a long time here, and it really means a lot to me. Now, for today's program, as promised, we are about to listen to an interview that Dennis McKenna gave to David Ellenbogen, and in which David played last night, it was the night before, on WKCR 89.9 FM radio in New York City. And David very kindly has allowed me to replay that interview for you here in the salon. And by the way, after we hear this interview, I'll be telling you about a new podcast that David's also started. But first, let's tune in as he asks a few questions of one of our elders who is deeply rooted in both the academic world and the world of the shaman. In past podcasts with Dennis's brother Terrence, there have been many occasions where we heard Terrence give Dennis the credit for coming up with some of the ideas that Terrence went on to champion on the lecture circuit, while Dennis worked in the laboratory. Now we are, at long last, getting the chance to hear some of these interesting thoughts directly from Dennis himself. So let's join them now.
Good evening. You are tuned to WKCR 89.9 FM New York. This is Studio A. My name is David Ellenbogen. So glad to have you. It's going to be a really interesting show. And that is because we have Dennis McKenna as our guest. Dennis McKenna is an author and an ethnopharmacologist, a well-respected scientist who's dedicated his life to exploring plants and their potential. If you find his ideas compelling, and I expect that you will, Google Dennis McKenna Kickstarter and you will learn about his campaign to write a book about his experiences with his brother, Terrence McKenna, one of the most radical philosophers of our time. So yes, if you get 3 things out of this program, one would be that you have a chance to be a part of what will be an incredible book, and it's going to be called The Brotherhood of the Screaming Abyss, written by Dennis McKenna about the wild adventures that he's had with his brother, internal and external adventures. And number 2 would be to inspire you to research the ideas of Terrence McKenna further. And number 3 would be that you might totally change the way you think about plants. So, yeah, we're going to dive in. This was pre-recorded at Dennis's friend Alexandra's house a couple months ago, before Dennis gave a talk about plants and creativity. So, let's dive in. And stay tuned. Thanks for listening. Well, maybe I'll start with a quote from Michael Pollan that exists in my iPhone. And basically, he states that a lima bean, when attacked by a spider mite, can release a volatile chemical that summons the species of another mite to attack that first mite. He mentions that, and he also mentions in the same quote that when they did research, when they did the Human Genome Project, they found that the human beings only had 25,000 genes, while a grain of rice had 35,000. So I wondered what does this say to you as a scientist?
Well, the part about the communication with the lima bean, or that example, is a good example of what I'll be talking about tonight, which is basically that chemistry is the language of plants in a certain sense, and plants are able to make all of this enormous biodiversity of what they call secondary compounds. They're not really secondary, but they're compounds that are not universally distributed among all living things. They're things that certain species or certain families make, and they're obviously not required to maintain life because not everybody makes all of these things, but what they are is basically a system of chemical communication that the plants use. These are messenger molecules, and the plants substitute chemistry or biosynthesis, as you could call it, for behavior. That's how they interact. Animals interact with their world through behavior, through the fight or flight or fuck reaction. We're always responding to stimuli from the environment in that way, and we respond through behavior, and we can move around and all that, and so this makes sense. Well, plants don't move around in the same way. They have ways to distribute their seeds and so on, but they just kind of sit there. But it's not that they're not doing anything. They are chemical factories that are communicating and maintaining a balance in this chemical ecosystem with everything else in their environment, which includes other plants of the same species, other species of plants, fungi and microorganisms in the soil, herbivores, which includes us, that might want to nibble on these plants, and sometimes they want to be nibbled, or that helps their reproductive cycle. Sometimes they want you to stay away, and so a lot of these things are toxins or repellents. Others are signaling molecules, and others are more symbiotic. They help establish and maintain symbiosis with other organisms, and that's what they do. That's how they communicate. And so it gets interesting. I mean, it's interesting in itself, but it gets interesting when we're focus on the relationships between plants and higher organisms like us, organisms with complex nervous systems, because plants have these neurotransmitter-like molecules too, right? In fact, that's where they came from ultimately. These things are signaling molecules that are uniquely suited to communication. And in evolution, these molecules, these neurotransmitter-like molecules, have become, they originally may have had an external communication type function, but then they have become internalized. And so the brain is essentially a communications network. It's, all this complex network of neurons with, that cross-talk to each other through these neurotransmitters. And it's kind of interesting to me that the neurotransmitters that are involved in the functions of consciousness, as far as we understand that, we know that serotonin, dopamine, epinephrine, norepinephrine are the so-called biogenic amines. And these are the main neurotransmitters that function in the brain in the areas that we know regulate consciousness. And these neurotransmitters come from amino acids. They come from amino acids, and they come from what they call essential amino acids. They're essential because we don't make them, right? We have to get them from our diet. Other things make them. We don't make those things, so we have to get them from our diet. So, these messenger molecules, essentially these plant molecules, are, we are plants in a certain sense. We get from our diet these neurotransmitter precursors that, then our body can convert into these neurotransmitters. So, were it not for the plants on that level, there would be, we wouldn't have these functions. Now, this business about the genes and the apparent paucity, or, the puzzle, we're so complex, why do we have fewer genes than a grain of rice? I don't know if anybody really has the answer to that, but, the paradigm that seems to be emerging, it used to be thought one gene, one enzyme, one gene, one protein. And that may be true, but a lot of what goes on, a lot of what's important in making these systems, our systems, so complex is post-translational. After the protein has been made, then it's modified by various factors, internal and external. It's cleaved in different ways. The proteins are made and come off the ribosome, and then they're usually modified in some ways. They may be methylated in certain places or chopped up into smaller fragments that then go off and do their function. So this whole realm of this is not genomics, this is proteomics. And the one gene may make one protein, but that protein may feed into multiple functions. And a single gene, it's not as simple a picture as it used to be. A single gene can make proteins that have multiple functions. And it's at that level that the complexity arises. So the fact that we have fewer genes than a grain of rice, I don't know if it still explains that, but it seems like on the proteomic level, the degree of modification that goes on following the synthesis of these proteins is much more complex. It must be, because obviously we think we're more complex than a turnip, say, but maybe not so much, maybe not as much as we thought, So I think that's kind of the current view, and it's one of those. It's a model, like everything in science is a model, and right now that's the best explanation for it. But it's still remarkable. It's not so much about genetics, it's more about epigenetics. And that's interesting because that opens the door to, other evolutionary mechanisms. It's not simply the simple Darwinian picture of natural selection. Becomes much more elaborated because it opens the door to environmental modification. For example, there's a very interesting theory there's a book called Left in the Dark, which is a theory about neural evolution that talks about the environment that early hominids evolved in was originally an arboreal environment in which their diet was mainly fruits, very little meat, but mainly fruits and other plants. And the net effect, the constituents in that kind of diet was very high in neurotransmitter precursors, neurotransmitter-like substances, monoamine oxidase inhibitors, essentially the chemistry that you find in pineal functions. And his theory is that this environment, influenced by the essentially chemical ecology that these hominids were evolving in, potentiated pineal functions. And those folks had a much more integrated kind of organization of their brains, where in our brains, our left brain is dominant in most people, and the right brain is the intuitive, creative brain, but it's usually the so-called inferior hemisphere. There's nothing inferior about it, but it's less accessible, right? And so most people, at least conditioned by Western civilization, are, analytical and more the left brain functions are more structured than the right brain functions, but the right brain is where the creativity is, and to a certain extent musical and mathematical abilities. This is all left brain stuff, and his theory was that these hominids in this environment had access to this, and that it wasn't a genetic effect, it was an epigenetic effect, because it modified the uterine environment of the female. So the fetus grows up in this environment that's essentially modeled, or in some sense influenced from the outside, from the diet of the mother. And the mothers are living in this environment. And so that has this epigenetic effect on the development of the fetus and the brain development of the fetus. As long as that environment continues, then it goes on from generation to generation. And you don't need thousands of generations for this to manifest. You need a few generations. But then, so this fellow's theory goes, the environment changed, the climate changed, these groups moved from the forest into the savanna, and their diet changed. They started eating a lot of grains, they started hunting animals and eating a lot more meat, they invented cooking, they didn't consume so many of these fruits, and they had, the pineal potentiation was suppressed. And the steroids from their animal diet has the opposite effect. It suppresses pineal potentiation. So gradually, what we think of as neural evolution, he's claiming is neural devolution, in a sense, that we lost this connection between the hemispheres gradually, and the right hemisphere came to be thought of as the inferior hemisphere, but it wasn't inferior, but we lost access to it in a certain sense, and that changed our whole relationship. We lost access to a whole bunch of functions that, for example, maybe things like telepathy, or just more intuitive integration with our environment. And as this continued, and it's only continued in our time, as our diet has gotten worse and worse, now our diet, the typical modern diet, has almost no relationship to nature. It's all processed foods and all that. So this is what, since this connection was lost, these somewhat less desirable traits having to do with our left brain fixations have become dominant. But the brain of modern humans is actually about only about 3/4 the size of Neanderthals, for example.
Our brain has shrunk.
Our brain has shrunk. Yeah. Now you have to take into account body mass and all that, because talking about brain size without talking about body mass is it doesn't make any sense, right? Because an elephant's brain is a lot bigger than ours, and so on. But they are not particularly intelligent. They're not intelligent enough to do what we do, which is create culture and language and all that. But that this relationship, over time has accelerated, and we become more and more estranged from the kind of functions that the right brain. It's not that it's not going on, it's just it's more in the background, and we're not always accessible to it. So a lot of these spiritual practices, psychedelics, meditation, various kinds of integrative things are techniques to try to re-establish this connection, to try to re-establish this, and potentially, the implications of his theory is that you could also, over time, if you were to change the environment, you could reestablish this and perhaps recover from this neurodegenerative disease that we have, which is known as civilization.
Our Western civilization.
Right. So.
Right. So to summarize what this last piece that you're saying, basically as our diet changed, we devolved from having a more integrated left-right hemisphere existence, and that led to a dominance of our left brain, which leads to male dominance,
exactly.
Anal thinking.
Exactly. All of those things.
And a war culture.
And a more or less suppression of the right brain by the left brain. The left brain kind of took over the executive functions, and the right brain, being the right brain, wasn't particularly interested in that anyway. So, okay, you guys go run things, and I'll just be here as the source of, all creativity and insight and all that. I don't know if it's
true.
True. It's a reasonable theory. And it explains a few things. One of the things about evolutionary theory or evolutionary biology that's always puzzled me, and this is kind of my main wrap for tonight's talk, and my main wrap in general, is that because of this plant communication system that works throughout the ecosystem, and it works on everything in it that interacts with plants, it just makes sense that secondary products, which work often at the genomic level and various levels, had an influence on evolution, in terms of the way that we adapted to this chemical environment. Some of the adaptations were behavioral, and some of them were genetic. Right, like for example, behavioral adaptations have to do with things like, purging, for example, or methods of cooking, or methods of detoxifying plants to make them edible. These are all simple folk technologies, but they enable the hominids to have a wider diet, to be essentially omnivores, because we've evolved those adaptations. But then over on the genomic side, there's also biochemical adaptations that are going on. There's, the liver is essentially the body's toxin filter in some ways. It's loaded with enzyme systems that have evolved over time to deal with these chemicals that come in from the environment, what we think of as drugs, which may be synthetic, but also natural chemicals. And everybody is a biochemical individual, right? And we know this now. There's a whole area of pharmacology that's a hot new area called pharmacogenetics. Everybody metabolizes drugs and toxins in a slightly different way, and that depends on the complement of enzymes that they have, whether monoamine oxidases, or there's another big set of enzymes called the mixed function oxidases, the so-called cytochrome P450 complex of enzymes, and these are inducible. You have the genetic blueprint to make them, but they're not made until you get exposed to a particular complex of toxins or a particular toxin in the environment, and then these things are induced by that environmental stimulus. It goes back to gene expression. The trivial and obvious example is an alcoholic, or a person who drinks a lot of alcohol has much higher levels of alcohol dehydrogenase, which is the enzyme, the primary enzyme in the pathway that breaks down alcohol eventually into, CO2 and water. But it inactivates the alcohol. A person who drinks a lot of alcohol develops tolerance because they have these, they're much less sensitive to it, whereas you or me, if we don't drink a lot of alcohol, that's why people can be, somebody can drink you under the table, right? Even though you're not consuming more than they are. They're consuming a lot more, but they're adapted to it. And for just about every class of toxins, there's a family of enzymes that is inducible, and those come online when you're exposed to the toxins. But a person living in the Amazon, say, that chemical environment is going to have a particular enzyme profile. If you isolated those enzymes and did HPLC or whatever, you'd see they have a unique profile that is a function of, or a consequence of the environment that they're living in. So you get the individual variations, but you also get the group variations. So a person in the Amazon is going to have quite a different profile based on their chemical environment than a person in Siberia or a person in LA, and they'll have a unique signature as well. So I think that, this is just a function of the fact that, we think of ourselves as separate from the environment. We're kind of here and our skin separates us from the environment, but we're not like that at all. We're semi-permeable membranes. Things are coming in all the time in the form of food, drugs, smoke, other things that we absorb, and we're putting out things all the time at the same time. So we're part of this chemical communication system, even though we experience it as being, this all happens at a fairly subtle level, and we're not necessarily aware of it, until you make some mistake, and then it's brought home, until you eat too many mushrooms or some poisonous plant and all that, and all of a sudden, didn't have the enzymatic machinery to take care of that one, so now we get to die, or whatever.
Right. So us being these semi-permeable beings, and I guess I've heard that a large percentage of our body weight is actually microorganisms and stuff like that, doing their own function. So as you're describing, we're basically this soup.
Yes.
But there's also the part of us that is speaking to each other, which is something else, or is it? Is that semi-permeable as well? I mean...
Well,
I guess we're talking about consciousness.
We're talking about consciousness, and so that's like a whole other level of interaction, mostly between us as individuals. I mean, there are chemical interactions as well, but we've sort of gone, because our brain has evolved to enable us to generate language, and language has all sorts of consequences that most animals don't really have to deal with. I mean, animals have primitive languages, but not languages that can carry signification. I mean, this is the main thing that they lack, is the ability to attach significance to symbols. Like in primates, language is a path. In a way, if it weren't for the linkage to symbols or significance, which are abstractions, right, we wouldn't be conscious. I mean, that is the sine qua non of consciousness, is that we're immersed in this world of ideas and abstractions and dreams and this kind of experience is as real as the external world for us, and not really separated from us. So, that's what sets us apart from animals. I don't think animals, I mean, you have to be careful to make these blanket statements, but I don't think animals are as modulated. Their behavior is not as modulated by symbols and things that are not external environmental cues, but internal constellations of ideas and emotions and so on.
Now, I know that prairie dogs can say such things as, there's a guy coming and he's wearing a red shirt and he's tall, or something like that. They've discovered this pretty recently, that they can. So what? Where is that symbolic speaking, or is what we're doing now? What makes what we're doing now on another plane than that, or is it not?
I think what makes it different is that what we can do is not necessarily linked to immediate survival concerns. I mean, a prairie dog sees the hunter coming, and it's important to get that signal out, and they do that, and that goes on. That's what most animal communication.
No, I think therefore I am amongst the
none of that, none of this philosophical stuff or these internal things, that go on, that you then integrate into abstractions and symbol structures, which we're immersed in all the time. We can't get away from it. I mean, the only way we can get away from it is by, well, I'm not even sure we can. Certain meditative techniques where the object is to have no mind, to just obviate all that and just be. I mean, it's hard to get to that place, because our brain is always chattering at us. It's always yammering, and the raw material of consciousness is kind of a mix of environmental cues and internal cues. And, if you think about it, once I had a DMT experience where I got what I thought was kind of an insight into this, where, it was powerful DMT experiences, they tend to be, and with experiences like that, the interpretation always comes later. When you're experiencing that, you don't really have time to analyze it. You're just, oh wow, But when you think about it, and the thing that, a model that makes a certain amount of sense to me, is that consciousness, the brain is an organ that likes to organize information, right? That's what it does. It takes in information and it routes it to certain parts of the brain, and there are internal processes that desperately try to have it make sense on some level to our cognitive apprehension. And so you take something like a drug that disrupts these neural processes and completely, kind of fries the wiring in a certain way, and yet what you experience from that seems to make sense, because even this kind of random neural noise is going to be structured in a way that patterns emerge out of it that have meaning or significance for us. So you can take something like DMT, and that basically floods the whole serotonin system with this alien molecule, with this non-natural neurotransmitter, completely disrupts the system, and yet what we experience is patterns and ideas and geometric structures and all that. That's what a lot of the brain does, is help to filter raw data of information, and that was the insight from the trip, that it was like the DMT allows you to rip the curtain back on this for a few minutes, or turn the circuit board over and see what the thing is wired like. And it's like you got all this information pouring into this big blender, and it's spinning around, and all this information, and it's it's something you read last week, it's a fragment of a song you heard 20 years ago, it's the first time you kissed a girl, it's something you read, something you heard. All of this stuff is spinning around, and the function of the brain is to mash that all together and come up with a coherent story, which is sort of the story of your movie, your personal movie that you're living in, your own hallucination, if you will, your reality hallucination. And but the DMT lets you tear that filter function away. You get to see the blender from the top. Normally it's separated from you by these curtains that are, the stuff is flowing through the blender, and it's all being shunted into the right places, and hopefully, unless you're completely disrupted, and we equate that to pathology often, but you get to see it you get to go behind the curtain and see the raw material of experience for a few minutes, and how it's all coming together in this very chaotic way that then the brain's ability to synthesize things takes over, and what comes out, it's like making pasta or something. You put a big gamish of pasta in the top, but these nice strings come out the bottom, and it's kind of like that, I think.
If you're just tuning in, this is WKCR 89.9 FM New York. My name is David Ellenbogen, and we are playing an interview I recorded with Dennis McKenna a few months ago. He's an author and a scientist, and if you'd like to take part in his newest creation, he is right now raising funds on Kickstarter to tell the story of his adventures with his famous brother, Terence McKenna. All right, back to the interview.
Now, to tie all this together, at the beginning you kind of said that consciousness itself comes from plants because it's the essential things. And then you're later having experiences through DMT, which is from a plant, which is giving you a new angle on reality. And we also spoke of the spider mites that think that they're doing what they want to do, but in fact are being controlled by a chemical from a plant, as is someone who's planting a rose thinks it's because they think it's beautiful, but maybe it's because the rose is also trying to survive.
Yeah, exactly. And this is the great insight that Michael Pollan has in this, and you read some of his books, you've read The Omnivore's Dilemma, perhaps,
yes.
And that's the point that he makes. We only think we're domesticating plants and growing plants, things like corn and that sort of thing. Actually, you can turn it around. Corn is growing us. Corn has turned us into its slaves. He talks about it as being the quintessential capitalist plant. It's adopted us, and it's forced us to change global agriculture.
Right.
Not in a good way a lot of times but as a dominant species, it's great for corn. Corn is more important in the Western diet, in the industrial food chain, than probably any other thing. It's not simply that we eat it, we get thousands of products from it. We get biofuels from it, we get all these things, and we're totally addicted to and dependent on corn. Well, corn is like, hey, I got an easy ride here, I'm not going extinct, because I have this protector. And
they have 4 senators now from Iowa and Nebraska.
Exactly. Yeah. And so it's a very successful plan.
Right. But what I was kind of getting at as well was that, is it possible that these insights that you had in this DMT experiences were insights that a plant wanted you to have?
Well, yeah, it's tricky. Yes, in some sense, in the sense that I think plants, it's to their advantage to establish these symbiotic relationships, like corn. Like, it's to its advantage to have us value it and grow it and use it, Does the plant want that? I mean, that attributes a different kind of intellect. That attributes a human-like intellect to the plant, and I don't think it has that. I don't think it exactly has that. It deals more on the evolutionary level. All organisms, to the degree that they can control their environment, they want to optimize their environment for comfort, for security, for reproductive reasons, maximize their chances to transmit those genes into the future. And by forming symbioses, I think that the process of plant domestication is essentially a symbiosis. So in the sense that the plant wants to have this evolutionary advantage, and here's this primate, that has the ability to domesticate it, to grow it, to take it out of nature, so it doesn't have to compete out there with all the other plants in the wild jungle. It can grow in someone's garden. And its evolutionary, fitness in some ways has just gone up several notches, because it can be, I'm not saying it thinks about these things, but if it did, it would say, hey, I'm in great shape until these knotheads destroy the planet completely. I'm good, I'm on easy street. And so I don't know that the plants want it as an individual, but it may be that as a community of species. I think as a community of species, what the community of sentience shared among living things in the biosphere understands on some level is that the whole global ecosystem is in peril. And it's always been in peril. If you think about it, we're facing ecological crises right now like we've never faced, but there were always ecological crises. And just the very fact that, we're this rock tumbling through space that's covered with slime, and we may be the only slime-covered rock in the whole mess, So it's inherently an unstable system. And life cleaves toward homeostasis. Life, wants to cleave toward stability. But not too much stability, because that's death. Right? But stability, it's homeostasis is the way life perceives it. It's an energetic state that is some distance from thermodynamic entropy. Right? That's what life is. They're negentropic systems. They're they're systems with a high degree of order. And in the physical universe, in the universe at large, those systems usually don't last that long, and there are so many influences trying to disrupt that order and essentially reduce it to chaos. And life pushes back against that, because they're not closed systems, right? They're these semi-permeable open systems where you take in nutrients and you transform them and you make the food part of your body, and that you can run the machinery of the brain, the machinery of the body on that. Eventually you always lose because you die, right? And that's true of species, of ecosystems, of planets, I mean, it's a losing game so far as we know.
But that's only if you define you as you, right? I mean, if you are just, as your brother kind of put it, there's a quote that I found very stimulating where he said, language is code, body language is code, and he went on to saying that everything is code, and what will reunite humans and machine is code. So if everything is code, then the code will go on. I mean, I guess maybe with the extinguishment of the Earth. I mean, still, the sun will still be changing hydrogen into different states and stuff like that. So,
well, these things will be going on, but code, the notion of code, goes back to the notion of message and the notion of significance. Is there a code if there's no mind to apprehend it? The notion of code requires a receiver, an interpreter, someone who is going to look at that information and out of that draw meaning or significance. If there's no apprehender, then it's not code. It's just what goes on, And what makes life different is that, it takes in these messages and they do have meaning. They do have significance. And so it's code in a certain sense, and the code is almost something that we put on that. Right. Well, in some cases it clearly is, but do these processes go on if there's no receiver of these molecular messages?
Well, the other thing about your idea that life is kind of a losing game because it always ends, I mean, that also assumes kind of a linear concept of time, right?
Yeah.
So if that is not the case, then maybe something else is going on.
If that's not the case, maybe something else is going on. And so far as we know, it's a losing game, in that. But it's kind of like, well, there's life, there's hope. As long as there are living systems, intelligent systems maintaining their, this distance from entropy, there's always a chance that you'll figure out a way to game the system and escape, into some other state of being where entropy does not rule. I mean, that's what I'm kind of amused by the cosmologists, who theorize about the ultimate death of the universe, because that's ultimately what we're talking, the heat death of the universe. And now the current model is that it doesn't collapse, it just expands forever,
freezes,
and eventually all the stars burn out, and and eventually there's not enough energy to even keep atoms together, and it just all kinds of peters out. Yeah. Right. So that's pretty depressing.
Right.
But the key thing that they leave out of these models, inevitably, is mind, is intelligence. Right? I mean, if intelligence exists in the universe now, and we're furiously trying to understand how things are structured and how it all works, isn't it reasonable to assume that in a few trillion years, if we persist, we're going to figure out how to get around this? We're going to move the whole system to some other state of being. We've got a long time to work on it, and there's no particular hurry. Right. I mean, there's a hurry for our planet, because, we've been very stupid. We haven't been good stewards of the planet. But you have to take some comfort, I think. I mean, it looks like we may not do it. We intelligent monkeys are really very stupid monkeys, and we're fouling our own nest, really. And we may destroy the planet, but there are lots of planets out there, and there's lots of life, and I think we're all part of this process of intelligence, trying to come to terms with being, trying to wake up to itself in a certain sense. I mean, I think that, and this gets back to, what we've been talking about. Is consciousness primary? Is consciousness something that, it's not something the brain generates. It's something that forms the ground of being, and what we have are these elaborate detection machines. Consciousness is something you detect, like tuning a television set to different channels, as much as it is something the brain generates. I think the brain modulates signals that come from outside, but consciousness is probably more primal than matter. In the beginning was the Word, right? And the Word was with God, and the Word was God.
Now you'll have to explain that more deeply, because I've heard people explain this, state this, but I never could really feel it on the visceral level that consciousness could have primacy over matter. I don't know. I don't even know where to start with that. I mean,
well, is consciousness generated by matter, or is matter generated by consciousness? And I think that's what in the beginning was the Word. That's the idea, was that, I mean, I'm not saying I buy into this, but there's the idea of, a primal and primary intelligence that puts meaning, the Word went forth. In other words, the act of signification, which is what words are, went forth in this primary way, and by uttering what some philosophers have called the logos, pure meaning, it triggered the eruption of this material efflorescence that we call the Big Bang, or that we call the origin of the universe. Now, it begs the question, in a sense, okay, so there's a being out there that sent the word out and started the whole thing going, started the clock ticking. No, it's not that it's separate. It's inherent in it. It's not that God is out there and God made the universe. The universe is God. It's trying to come awake to itself, and it exists. In the current view of it is there's this quantum foam. These what is the term? These vacuum fluctuations, which you've heard of, right? Vacuum fluctuations.
I haven't heard a lot about it. I mean, certainly anything quantum I don't understand.
Well, vacuum fluctuations, they're not that difficult to understand, but there's something that's an observed phenomenon that in particle physics, you can look at this stuff in cloud chambers and that kind of thing, where there's nothing happening. It's a perfect vacuum as far as you know. But all of a sudden, an electron and a positron and a proton appear out of nowhere. Mm-hmm. And they exist for a tiny fraction of a second, on the order of Planck's constant, and then they come back together and annihilate each other, and everything's back to, this kind of quantum foam, this sea of potentiality. Mm-hmm. And usually these quantum fluctuations that we can study in the lab are, a few particles, a few dozen particles. But there is no upper limit, there's no theoretical limit on the size of a vacuum fluctuation. Mm-hmm. And a vacuum fluctuation could be as big as the universe. And that's kind of the current idea. That's essentially how things came into being, that there's just this quantum foam of, particles appearing and disappearing, and somehow, for some reason, a bubble forms, and this one, doesn't disappear in a microsecond. It lasts trillions of years.
Right. Or it's all relative, right? I mean, it could be a microsecond compared to another.
Yeah, absolutely.
Sense of
yeah, absolutely. And this is going on all over this sort of quantum ground of being, this foamy substrate. And so there are multiple universes, and some are very short-lived, and some are medium-lived, and some are quite long-lived, and it is all relative.
And that's much more hopeful than the heat death model.
Well, absolutely, it's hopeful. And it's hopeful, and I don't like the idea of the heat death. I mean, that's pretty depressing. It's all just gonna... But... It is more hopeful because within some of these bubbles, some of these quantum fluctuations that have a long lifespan, it's long enough for life to evolve, intelligence to evolve. And once you've got that, and once you've got intelligence with an ability to manipulate the environment, then all bets are off, as to the fate of that particular system. But chances are, life and intelligence, because it wants to persist, will get busy and figure out a way to escape from this constraint that everything must return to entropy. So,
and you seem to be the only guy getting grant money towards this.
Well, I'm not getting any grant money for this.
I understand you are. I mean.
No, I'm not getting any grant money for this. I mean, just...
You've got grant money to go down and study what the shaman have to say.
But I do, but the grants come because we don't talk about any of this.
Exactly.
We don't talk about the wider implications. You have to focus your science, very specifically on something, and you can't let people know that, you're really a wild-eyed screwball. You have to play the role of, I'm a serious scientist, I'm a reductionist, I just want to look at, the chemicals in plants and see how they work, in biological systems. But you can't get grant money for this kind of thing. I mean, you can get a fast ticket to an insane asylum if you talk about the wrong people. You have to be very careful. But we all have these intuitions. There's nothing that's unique to me about this. I mean, I think any thoughtful person has got to be, in some ways astonished, that we're even here. I mean, the whole shooting match is so bloody unlikely, given that, the universe is entropic in most of its parts that we know. The fact that we're here is a marvelous thing, on the order of a miracle. Thank Gaia, thank God, thank whoever you want to thank that we are here. And, the whole, when you really think about how unlikely this is, given what we know about the way things are organized, I mean, some incredibly unique event took place here. And hopefully it's not unique. Hopefully it's the norm. I mean, this is a big question. How prevalent is life in the universe? And I mean, I'm reasonably confident that if you have complex life forms, sooner or later you're going to have intelligence. It's this property. It's this emergent property notion. If you have an environment that's prebiotic before life, but if the chemistry is complex enough, you've got complex chemical systems. A lot of these organic compounds, including amino acids and nucleotides and all the building blocks of life, can spontaneously form in abiotic or prebiotic systems. I mean, this has all been worked out years ago, simulate the atmosphere of primitive Earth and shoot lightning bolts through it or whatever, and amino acids will rain down out of that medium. So this is a property of matter. This is just what carbon chemistry does. But at a certain point, the complexity will go over from organic chemistry to biochemistry as these systems begin to surround themselves with membranes, for example, and sequester certain molecules in certain compartments, and then they're closer together and they can interact, and you get enzymatic systems going on. Enzymes are usually simply a way of accelerating a chemical reaction that would take place over time anyway, but slowly, and not fast enough to really have much consequence. So you get out of complex organic chemistry, you get primitive life emerging as an emergent property at a certain level of organization, and then you have more complex multicellular systems emerging, and then they become complex enough that you can get compartmentalization, specialization into organ systems, multicellularity in a sense. And so you can get specialized systems that, are adapted to particular functions. And of course, for us, the most fascinating one is the neural systems, these evolved systems of chemical communication. And knowing what we know about the way that matter works and chemistry works and so on, we can be reasonably sure that, other places in the universe, other places in the galaxy that simulate the environment that was on the primitive Earth, those systems will also evolve life. It's just an inevitability. It's a property of matter. So that's reassuring because, there
takes a lot of the pressure off.
It takes a lot of the pressure. Yeah, it's not only up to us. It's not only up to us. Life probably permeates the universe, and that means intelligence permeates the universe. And that's good. That's so, if we blow it, and looks like we're probably going to, but others will carry on, and if we wake up in time, maybe we can be part of that. I mean, that seems to be our challenge, is to, propagate these understandings through enough people that people do wake up and they realize we've got to get cracking.
And what are the methods that people do that you see as ways that people could open their eyes or wake up to these larger issues?
Well, I think that's where the psychedelic plants come in to play a big role. I mean, I think that these intelligent plants, the plant teachers, if you will, the ones that the shamans have had this symbiotic relationship with for millennia, since long before history began, they're part of that message. I mean, they're trying desperately. It's almost like they're emissaries from the rest of the biosphere who have come forward, who have always been there and have always been recognized by some, but now they're exploding on a global scale, with the internet, with the widespread interest. I mean, ayahuasca is now a global phenomenon, and this is part of, the plants reaching out, trying to reach out to larger groups of people and basically, hit us upside the head with a 2x4 and say, hey, you monkeys, wake up. You're fucking it up. You have to wake up. And I think that's what they do. So I think that that's a big part of why we're in some ways returning to we never really left it, but this archaic fascination with these plant teachers is certainly a whole lot more out there than it was a few years ago. Mm-hmm. And I think because people are making these discoveries, but people being people, there's all sorts of things you can do with that knowledge, and people being people, some of it's not necessarily good. People people receive the message, and then the next thing you know, they're the Messiah. They have to save the world. It falls on their shoulders to be the one, and they're going to lead humanity into this post-historical age. And what's lost there, a lot of what's lost there is humility. And I think humility is essential for doing this. I mean, this is the other thing that, to me personally, and I think to a lot of people, I think this is the message of the plant teachers. Not only, you monkeys need to wake up, but you monkeys need to get over yourselves. You monkeys only think you're running the show. You're not running the show. If anything, the plants are running the show. And this we know because plants are through photosynthesis, they're the basis of life on Earth. They're the mechanism that life has evolved to grab solar energy out of the cosmos and use it, convert it into chemical energy and use it to run this biosphere, much in the same way that we use nutrients or food to run our little ecosystem, this biochemical engine that we are. And that's really what the biosphere is. I mean, you can think of it as a cell as much as anything. So I think that the plant teachers are important in helping people to make these discoveries. And then the natural impulse is to propagate that message, to spread the good news or to spread the news in a sense. But it's also, we tend to think that we're important, individuals are important, so there's a real tendency to, on our part, to place yourself right in the center of that and say, it's all about me. It's I'm the Messiah, I'm the person who's going to propagate the message. And it's not an unhealthy impulse to want to let people know, but there's a temptation to say, well, I'm going to found a religion, or I'm going to found a cult, or I'm going to, and then the sort of the purpose of the whole thing gets lost, the purpose being to wake people up, but suddenly, or not suddenly, but over time, that purpose becomes obscured. And the purpose becomes to perpetuate the institution, or the individual, or the structure of the thing. And so the central mystery, which may have come from a plant teacher or other sort of one-on-one direct revelation, reception of a message from the cosmos, or a learning, a teaching from the cosmos, becomes obscured. And it was like, because real mysteries are inherently threatening to institutions, and even if they had their origin in a revelation, the institutions become rigidified, and it's like, oh my God, we've got to suppress this. Only the priests get to know that this all came from eating mushrooms or whatever it came from. We can't tell the rabble this, because then they won't obey us, they won't look up to us. So that's also, sort of my shtick when I talk about this stuff is, don't follow, or preserve your inherent right to think for yourself and question everything. Religions talk a lot about faith. And I guess we all have faith in certain sense. Like I have faith that life is common in the universe, and there's evidence for that belief in what we were talking about, the nature of physics and chemistry and all that. I have no hard evidence that there's life anywhere else in the universe, but I take it on faith with a certain amount of evidence that there probably is, there's likely to be. Religions, established religions, tend to want you to take a lot of things on faith for which there's not a shred of evidence. You know, and so the doctrines and the dogmas become essentially, they're political institutions. They become instruments for keeping people in line. Don't ask too many questions, just accept it, you know, because we're smarter than you and we're running things, so you must have faith, my son.
Right.
You know, why in hell should I have faith? You know? Give me a reason. I prefer evidence, you know, and I mean, even just a little evidence would help. So I think that's one of the dangers of, you know, getting these revelations, and it just seems part of the natural evolution of these things, that's how people react, you know. With psychedelics, it's almost a side effect of psychedelics. One of the maybe adverse side effects of psychedelics is it'll make you think that, you know, you're the Messiah, or you have to somehow play a role in this. And I don't think so, in a way. I mean, I think ayahuasca, you've got to look at it from an evolutionary perspective. And what's playing out here is plant-human coevolution. It's been going on for tens of thousands of years and possibly longer than that. Now it seems to have gone to a new stage. But I think ayahuasca is perfectly capable of finding the people it needs, and the people that need to find ayahuasca will find it. And there's no need for cults or movements or very much human intervention, although a lot of people will be convinced that we must do this.
You're listening to the Psychedelic Salon, where people are changing their lives one thought at a time.
Well, now you know why Terence was always so generous in his praise of his brother Dennis. Together, they made quite a team, and now it's up to Dennis to continue not only the scientific research work that the two brothers began so long ago at La Chorrera, but as you know, Dennis is also right now working on writing the definitive biography of his famous brother and their many exciting adventures together. Now, I've talked about this project in recent podcasts, but as of now, with only 20 days to go and only 585 backers for Dennis's Kickstarter project, I want to mention it one more time in the hopes that he'll get enough pledges of support so that he can proceed with this important project. And for what it's worth, I've pledged part of the donations that we've been receiving here in the salon this year towards the project. So thank you again to all of the saloners out there who have made contributions not only to the salon, but to Dennis's project, to the Shulgins, and to all of the other worthwhile causes that seem to be calling for our help these days. And another way we can help, all help one another, I think, is to support each other's projects in ways that don't involve money. And I'm talking, of course, about spreading the word about what other people are doing. For example, today I'd personally like to thank Dennis McKenna, David Ellenbogen, and WKCR 89.9 FM radio in New York City for providing the informative interview that we just heard. And I also want to mention that David has also begun podcasting. And his program can be found online and in iTunes if you go to NYC Radio Live. That's online at nycradiolive.org. Or search in the iTunes store for NYC Space Radio Space Live. Not all one word there. And while I've had a long-standing self-imposed rule to only plug podcasts after they've had, say 10 or more programs, but after listening to David here in the salon and after listening to his first podcast, I think that this program is one that's going to be around for quite a while. So if you're interested in jazz and world music, maybe you want to check it out. Not only will you hear some new music, but you'll also be treated to in-depth interviews with the musicians that are being featured. I really enjoyed that first podcast, David, so thanks again for all you're doing to make this world a nicer place. And I should also mention that on David's website you can hear some of his own music, which I find quite enjoyable and will probably be featuring in some future podcast. Well, that's going to have to do it for today, and so I'll close again by reminding you that this and most of the podcasts from the Psychedelic Salon are freely available for you to use in your own audio projects under the Creative Commons Attribution Non-Commercial 3.0 license. And if you have any questions about that, just click the Creative Commons link at the bottom of the Psychedelic Salon webpage, which you can get to via psychedelicsalon.us. And if you are interested in the philosophy behind the salon, you can hear a little bit about it in my novel, The Genesis Generation, which is available as a pay-what-you-can audiobook that you can download at genesisgeneration.us. And for now, this is Lorenzo signing off from Cyberdelic Space. Be well, my friends.